Many of you have learned that there are two or three special triangles. Some of you learned two, some of you learned three. It really depended on how you learned about these triangles. Now, I'm going to expand this to create five important triangles. These five important triangles are built using five principal angles: 0, pi by 6, pi by 4, pi by 3, and pi by 2. Now here you'll see that 0 and pi by 2 are simply horizontal line and vertical line, and we're going to call them a quote-unquote triangle. And here our angle here is angle equals 0. And here our angle is pi by 4 by 2 degrees. So with sine of theta is going to equal opposite over hypotenuse, which is 0 over 1, and which is equal to 0. And our cosecant of theta is going to equal 1 over 0, which is undefined. Now, one thing to note about this special triangle is it can be summarized with opposite equals 0, adjacent equals 1, and hypotenuse equals 1. And we're going to jump down here and talk about our vertical line here. Here, the hypotenuse equals 1, but our opposite angle equals 1 as well, whereas our adjacent side is equal to 0. So now here, let's look at cos. Cos of theta equals 1 over 1, which equals 1. And secant of theta, which is our hypotenuse of our adjacent, is 1 over 1, again, equals 1. Now, tan of theta equals opposite over adjacent, or 0 over 1, which equals 0, whereas our cotan of theta equals 1 over 0, which is undefined. Now we have pi by 6. Now with pi by 6, our sine of theta is going to be 1 over 2. And our cosecant of theta equals hypotenuse over opposite, or 2 over 1, which equals 2. Our cos of theta is root 3 over 2. And our secant of theta equals 2 over root 3. Our tan of theta equals 1 over root 3, whereas our cotan of theta equals root 3 over 1, which is equal to root 3. Going to our pi by 4 special triangle, sine of theta equals opposite over hypotenuse, 1 over root 2. Our cosecant of theta equals root 2. Our cos of theta, root 2 over 1, which equals root 2. Our cos of theta equals adjacent over hypotenuse, which is 1 over root 2. Whereas our secant of theta is hypotenuse over adjacent, which is going to be 1 over 2 or root 2. Our tan of theta is opposite over adjacent, which is 1. And our cotan of theta is going to be adjacent over hypotenuse, which gives us 1. Completing this chart, we can see that sine of theta for pi by 3 is root 3 over 2, whereas cosecant of theta is 2 over root 3. Cos of theta equals 1 over 2, whereas secant of theta equals 2 over 1, or 2. Tan of theta equals root 3 over 1, or root 3. And cotan of theta equals 1 over root 3. Now for our final special or important triangle, sine of theta equals 1 over 1, which is 1. Cos of theta equals 0 over 1, which is 0. Oh, wrong box. Our cosecant of theta is going to be our hypotenuse over our opposite, or 1 over 1, also equals 1. our cosine of theta equals adjacent over hypotenuse, 0 over 1. Whereas our secant of theta equals 1 over 0, which is undefined. This equals 0. Finally, we have tan theta equaling 1 over 0, which is undefined. Whereas cotan of theta equals 0 over 1, which equals 0. So we have our special triangles. And with these special triangles, I like to just draw them on the Cartesian plane and use cast rule like we did before. So we're going to do a couple examples with these special triangles. Okay. Now, when we solve our trig expressions, we're just going to have a little bit reminder that the hypotenuse is always going to be positive. The opposite going up, the positive value, or the opposite side going down is a negative value. The adjacent side is right, it's positive. If the adjacent side is left, it's negative. So if I draw my chart here, when I create my triangle, no matter where it is, this here will always be positive. That hypotenuse is always going to be a positive line. But this here would be negative because it's pointing down, and this would be positive because it's going to the right. Okay? Whereas if we draw this triangle here, this would be positive because my hypotenuse is always positive. But this here is negative, and this is positive. Okay? We can continue to draw our chart. This here is going to be positive. This here is going to be negative. Okay? So we get that kind of picture. So let's take a look at our cos pi by 3, or cos 2 pi by 3. If we draw our Cartesian plane and we draw our 2 pi by 3, I end up here. I'm past pi by 2, and I'm before pi by 3. Now, solving for the angle, I'm going to get pi minus 2 pi by 3 is going to equal 3 pi by 3 minus 2 pi all by 3, which is pi by 3. So this angle here is going to be pi by 3. Now, pi by 3, if we recall from our special triangles, we're going to have 1, root 3, and 2. But now we should put in our signs. So this is going to be positive while this is going to be negative. So negative, positive, positive. And cos 2 pi by 3, well, cos equals adjacent over hypotenuse, which equals minus 1 over 2, or minus a half. Okay. Now, what about cosecant? Well, cosecant, I'm going minus 3/4, which lies here. I draw my triangle. I want to find out what this angle is. Well, minus 3 pi by 4 minus pi equals, or minus negative pi equals pi by 4. So my principal angle is pi by 4, which means it's going to be 1, 1, root 2. This is going down, so it's negative 1. This is going to the left, so it's also negative 1. Cosecant equals opposite, or hypotenuse over opposite, which equals root 2 over minus 1. So it's minus root 2. And for tan pi by 7 pi by 4, once again, we're going to draw our triangle. We're going to go 7 pi by 4, which goes all the way around to here. We draw our triangle. And now my angle is going to be 2 pi minus 7 pi by 4, which equals pi by 4. So in here, my angle is going to become pi by 4. With pi by 4 being my angle, I am a 1, 1, root 2 triangle. This is going down, so it's negative, whereas this is going across, so it's 1. Now this equals opposite over adjacent, which equals -1 over 1, which equals -1. Now we've gone through and we've solved through what tan 7 pi by 4 is, but using this triangle buildup and then what your angles equal, you can quickly solve for your other trigonometric ratios. So for each of the angles we've just solved, we did cos, cosecant, and tan, solve the remaining trigonometric ratios. Next, we have an example where we're given what cos is. We're told cos is this number, and then we're told that theta lies in a certain range, and we're asked to compute a different trigonometric ratio. So the first thing that we need to do, or the first thing that I like to do here, is just highlight where the angle lies. So I'm told that it lies between pi and 2 pi. So it lies down here. And then I'm also told that the ratio is 5 by 7. Now, cos is positive, and in this interval is down here. That's where I'm going to lie. Okay, so this is going to be my triangle. And 5 by 7 means, well, my adjacent is going to be 5, and my hypotenuse is going to be 7. Well, now to solve for this last angle here, we're going to use the Pythagorean theorem because this is a right angle triangle. So a squared plus 5 squared equals 7 squared. A squared plus 25 equals 49. A squared equals 49 minus 20. A squared equals 24. Taking the square root of both sides, we get a equals plus or minus root 24. Now, we don't know just from isolating whether it's going to be plus or it's going to be minus. Here, because we're going down, that root 24 is going to be minus root 24. And now that we have our triangle, we can now compute any of our trigonometric ratios. Well, cotan of theta, recall this here is my angle theta, but I'm going to compute it using my principal angle. Cotan of theta is equal to adjacent over hypotenuse, or opposite, sorry. So this is going to be equal to 5 over minus root 24, which equals minus 5 by root 24. I highly suggest practice computing the final angles. Now, we have a bunch of trig identities that we're going to be using. These trig identities, we have our Pythagorean trig identities, which are that the cos squared plus sine squared or sine squared plus cos squared equals 1. And these other two identities come from dividing by sine squared or dividing by cos squared. These are used in various places. Then we have our double angle formulas. Our double angle formulas are how we go from having a single angle to two angles. These double angle formulas come up in various locations. These half angle formulas, these are used heavily when integrating. So when doing integration, we heavily use these angles. Then we have our addition formulas. And our addition formulas are used in various locations. And then we have transformations. Ways and things we can do, we can add by a period, subtract by a period. How does it change our function in those ways? I would say that knowing this identity, these identities, these identities, and these identities are the most important. So those are the most important. The next thing I would say is the fact that sine is an odd function and cos is an even function is your next most important idea. Then after that, it depends on how often it's going to be used.